All right, so section 12.2 or 12.3, we need to be able to find least common denominators. So reviewing just how to do that with a fraction will help us to see how we do it with a rational expression. So remember, with a fraction, we had to get the prime factorization of these. So we got prime factors of each of our denominators, such as the denominators of 2/15 and 7/36. And once we had those, we rewrote these as prime to exponents, and then once we had the exponents written, then we could say, okay, now we need to see what the unique factors are. So up here I see 2's, 3's, and 5's. So I wrote down 2's, 3's, and 5's. And then from there, I said, okay, what's the highest exponent of each of these factors? So the 2's, I see the highest exponent is a 2. 3's, I have a 1 there and a 2 there, so higher is 2. And then the 5, there's just the 1 there. And so then my least common denominator would be 4 times 9, which is 36, and 36 times 5, and 0 carry the 3, that's 180. And so that would be my least common denominator in that particular instance. And so now what I would have is the process described here that I'm going to use for when I have a polynomial. Polynomials, remember, factoring them is getting their prime factors. So it's the same thing as I've done here. So here I have a prime factor. And here I have a prime factor times a prime factor. Those are unique prime factors. So in finding my least common denominator, I'm going to see that I have the unique factors of x and x plus 5. And then I want their highest exponents. So the exponent on this x is 1 and this is 1. Remember, not adding those up. It's the same thing as before. You only get to choose one. So it's x to the first power. And then the x plus 5, we see the first power as well. And so the least common denominator here is x times x plus 5. Now let's take a look at our second example. Just like with the numbers, we need to find the prime factors. So when I see this polynomial x squared plus 3x plus 2, the first thing I have to do is get its prime factorization, which means factoring it. That's what we practiced for an entire chapter, is factoring them. So I need the factors of 2, 2 and 1, that sum to 3. So there we go. Now once I have these factored, then I'm going to say, okay, my least common denominator then is the unique factors that I see. So I see x plus 2 and x plus 1 and x plus 2's. So x plus 2's are unique and x plus 1's are unique. And again, I have to be very careful not to make the same mistake that I could have made with numbers, right? Just because I see 2 of these x plus 2's does not mean that my LCD has an x plus 2 squared. It's the highest exponent. So remember, I get an x plus 2 only one time, because which is higher, 1 or 1? Well, neither of them are higher, but I only get to choose one. So I get the x plus 2 to the first power and the x plus 1 to the first power. And that will be my least common denominator. So that's our review of finding a least common denominator. Now the next thing that we're going to want to do is we're going to want to build higher terms. So again, we're going to start with the fraction examples, and we're going to see how to build higher terms with the fractions. And then once we get the higher terms, then we can proceed on with the adding and subtracting. So in the next video, I'm going to show how to build a higher term.